today we're going to talk about data modeling. We'll talk about what it is, why it is important, and why developers need to pay attention to it. And then we'll explore some of the concepts behind data modeling using an example for a relational database model. Thanks to those who have subscribed in the past, our subscriptions are growing. We moved from 10 to 14 to 16 subscribers. And don't forget, the target is to get to 1,000 subscribers before the month ends. So if you're watching and you're not subscribed, please subscribe, like it if you get any value out of this video. Today we're going to look at data modeling. What is data modeling? Why is it important? Why should developers pay attention to it? And then we'll explore an example of data modeling under the concept of relational database systems. Every day, 328 million terabytes of data is generated. And this data is generated worldwide by people using their apps, social media, banking, IoT devices. All are constantly streaming data around the world. As a developer, your primary concern is how do you build applications? What are applications all about? Applications are concerned with collecting, storing, and retrieving data. This is what creates value for the users. So which means applications are just a layer above data. The real concern for applications is data. How do you collect data? How do you store data? And how do you retrieve it in an efficient manner? So as a software developer, it pays for you to be concerned about data. And since you're building applications that solve problems in the real world, you need to be able to model the real world in your software. And this is where data modeling comes in. Data, in the context of software architecture, falls under persistence. And when you talk about persistence, there are several ways you can persist data. You can persist data using files. You can persist data as objects. You can persist data in relational databases. You can persist data in NoSQL databases. So the data modeling I'll be talking about in this video is about relational database modeling. That is, modeling data for relational databases. Relational database modeling is about creating relational database schemas. And relational database schemas are basically a blueprint for how you're going to collect, store, and retrieve data. It defines the entities, the attributes for these entities, and the relationships between these entities. In addition, it's also concerned with the constraints which exist between these entities. Relational database modeling also involves representing your relational model visually. This is done through entity relationship diagrams. Relational database modeling is a timeless skill. It's also technology agnostic. So it's important for developers to learn this skill because developers who know how to model data are way better than those that don't. Now, modeling data is tough, it's hard, it's sometimes very complicated. We'll talk about the pros and cons later, but just know that these are the kind of things that make developers avoid modeling their data when they're building applications. But then this leads to a lot of problems down the line with their application. So to make you understand the concept of relational database modeling, we're going to look at an example. In designing a relational database model, there are three things you need to do. You need to identify the entities, and for each entity, you need to identify which attributes you need to collect and store for each entity. You also need to identify the relationship between these entities, and as well as the constraints. So let's look at an example. Let's say we want to create a relational database model for an estate, a gated community. So the first thing we need to do is identify the entities that make up our model. So for our example, we'll be concerned about collecting data about the estate itself. We'll be concerned about collecting data about the streets within the estate. And then we're also concerned about collecting data about the houses within the estate. So we've identified our entities, the estate, streets, and houses. The next thing we need to do is to identify the attributes we need to collect for each one of these entities. So for the estate, we need to collect things like the name of the estate, the address, the contact phone number, the email of the estate. For the street, we need to know what the street name is and probably the number of houses you can find on each street. So for the house entity, we need to know the house number, the type of house, and number of bedrooms. Now, the next thing we need to do is identify what the relationship between these entities are. So we can say an estate contains streets and streets have houses. So there we have identified how these entities are related to each other. Now, in relational database modeling, there is a concept of cardinality. So for example, the cardinality between estate and streets is a one-to-many relationship. This is because an estate, a single estate, can have many streets. So estate and streets is a one-to-many relationship. Streets and houses is also a one-to-many relationship. This is because a single street can have many houses, but a single house can only be on a single street. A single street can also be only in one estate within the context of our model. There are also other types, a one-to-one relationship or a many-to-many relationship. A many-to-many relationship exists when several instances of a particular entity can contain several instances of the other entity and the other way around. A quick example would be someone can place multiple orders and a single order can contain different types of products. A single product can be found in different types of orders, right? So the relationship between orders and products is a many-to-many relationship, and there are certain ways you model that kind of relationship. So this represents the model for our database schema. We have the entities, we have their attributes, and we have identified the relationships between them. Now, a critical step is how do you take this now and represent it in the language of a relational database system? So for us to represent our model in an ERD, an entity relationship diagram, each entity will end up being a table. The attributes become the columns, and when we have records inserted for each of these entities, that's where we have the rows. So each row represents a record, and each record is an instance of the entity. You can see that we've added an ID column to each of these tables. This is because the ID uniquely identifies each record. It uniquely identifies each instance of the entity. These IDs also help us to show the relationship that exists between these tables. When you look at the street table, for example, you see there's another column there for entity ID. Entity ID in the street table represents a foreign key. This is because entity ID is a primary key in the entity table, which uniquely identifies each instance of an entity. But because you want to show the relationship between street and entity, the street has a column for entity ID. And in the street table, this is the foreign key. And the same thing applies to house. So IDs help us to uniquely identify entities and to establish relationships and to also define the constraints between these entities and tables. So from our very simplified example, you can see the effort it takes to come up with a model. Now, this is a very trivial example. In a real life situation, it's going to be a bit more complicated than this. And this is why developers don't tend to do relational database modeling. They tend to skip it and just go straight into coding, which gives them the illusion of moving fast, but creates problems later down the way. So we're going to talk about the pros and cons of relational database modeling. So why is it important to model data? So I think one of the biggest advantages of data modeling, at least for me, is it helps you to really understand the problem you're trying to solve. It forces you to think critically about the problem. It forces you to analyze the problem deeper because you're thinking about data, how it's going to be collected, how it's going to be stored, how it's going to be retrieved, and how the data will move. It's one of the most complicated aspects of building software. So data modeling is a tool that helps you understand your problem even better. Another advantage of relational database modeling, so it helps you improve data quality by making sure that you can't insert records into the database anyhow because you've already identified the entities, the relationship, and most importantly, the constraints between them. Data modeling forces you to think about how the data will be used. It forces you to think about how data will be stored and retrieved. By the way, data is retrieved using structured query language, SQL, or SQL as some people like to call it. This generally means that your application will perform better if you do some data modeling upfront. So what are some of the disadvantages of data modeling? Well, the obvious one is it takes time. If you're going to do data modeling, it's going to take you a longer time to think about it, do the designs, come up with the model, and which slows things down. The other disadvantage is once you've come up with a data model, especially for complex situations, it's usually very hard to change. Anything that has to do with data or the data layer in any application is hard to change. So despite the disadvantages, I still recommend that you put some effort into data modeling for your projects because the benefits outweigh the cons. And as a developer, if you understand database modeling, you are way better off than a developer that doesn't, whether you are doing back-end development, front-end development, or even UI UX design. If you understand data modeling, it helps you a lot in each of these layers. So thank you for watching this video. The whole idea was just to give you a very high-level overview about the concept of relational database modeling. If you haven't subscribed, please subscribe. We're trying to reach 1,000 subscribers. So far, we only have 16, but we are very hopeful that by the end of the month, we would hit our goal of 1,000 subscribers. And we'll see you in the next one.